Hello and welcome to this video on AcouS STIFF. I'm going to show you a brief presentation of the model in this software. The toolbox is composed of three tabs: Assembly, Ties, and Materials. Two basic components are defined, the simple wall and the porous materials. These components are directly available in the Material tab. The simple, with the gray icon, and the porous, with a yellow icon. The other models are available in the Assembly type. The multilayer is the stacking of single non-bounded leaves and assumed free to move independently from one to each other. We can construct two plaster boards screwed one to each other with the multilayers. The wall line with porous materials simulate a porous materials associated with a single wall with or without contact, like a lining system with mineral wool on the concrete floor. So I can simulate the concrete floor and the glass wool. The double leaf wall simulates a mass spring mass system with an intermediate cavity fulfilled with air and/or mineral wool. A mechanical contact can take into account with the ties: linear, surface, point, or peripheral ties. So I can insert linear ties, and we can simulate, for example, a partition with plasterboard and mineral wool in the cavity. In the same way, the triple and quadruple leaf wall simulate a system with several masses and springs. So some complex constructive systems with lining on each faces can be simulated. The isotopic wall simulates constructive system with several rigidities in different ways, like the hollow bricks, masonry, or wooden floor. Finally, the honeycomb slab simulates alveolar concrete slab with the geometric parameters, with or without topping slab. Now, the operations on air index. The operations on air index includes the possible operations on the simulations or acoustic test reports of sound index reductions. The heterogeneous wall simulates wall constructive components of several elements with different sound index reductions and different surfaces. So I can take, for example, the double and the multi-layers with different surfaces, and calculate the sound index predictions. The arithmetic sum and the delta R enable to add or subtract sound index predictions to know, for example, the acoustic performance of a lining system. And finally, the test reports wall enable to insert test reports in the operations on air index. So we just browse the different model in the software AcouS STIFF. Thank you for your time, and I invite you to consult the other tutorials for more details on AcouS STIFF models.